Welcome back to our 7th video on basic SQL. Why don't we talk about the select statement for a while? Let's get started. SQL has one basic statement for retrieving information from a database, the select statement. Before proceeding, we must point out an important distinction between SQL and the formal relational model discussed in some of our previous lectures. SQL allows a table to have two or more tuples that are identical in all their attribute values. Now that's a violation of relational database principles. SQL will allow it. So it is up to the designer to make sure that there is some piece of information there that makes each tuple unique. Hence, in general, an SQL table is not a set of tuples because a set does not allow two identical members. Rather, it is a multiset of tuples. Some SQL relations are constrained to be sets because a key constraint has been declared or because the distinct option has been used with a select statement that we'll discuss later. We should be aware of this distinction as we talk about these examples. Regardless of what SQL will allow, most designers use a proper relational model when designing a database. The basic form of the select statement, sometimes called a mapping or a select from where block, is formed of the three clauses select, from, and where, which has the following form. The select is a list of attributes that you're wanting to pull from the existing tables. From defines which tables those are. And where identifies a condition that you want to implement with your select statement. For example, the date of birth is prior to January of 1991, something like that. Or department equals operations. So we're pulling a set of employees out of the employee table. The where statement is allowing us to apply a condition where it only pulls employees from the operations department. In SQL, the basic logical comparison operators for comparing attribute values with one another and with literal constraints are equal, less than equal to, greater than equal to, and not equal to, which is the less than, greater than symbols side by side. SQL has additional comparison operators that we will examine gradually. The select clause of SQL specifies the attributes whose values are to be retrieved. This is called the projection attributes. And the where clause specifies the Boolean condition that must be true for any retrieved tuple. This is known as the selection condition. Let's look at a couple of examples of what we've just described. Here's query 0. Retrieve the birthday and the address of the employee whose name is John B. Smith. Now, if that's what you want to do, the statement would be select B-day and address, which are the two attributes in the table that we want to see, from employee, that's the table we want to pull them from, where F name is equal to John, and you notice it's in single enclosed quotes, and statement, midnit is equal to quote B, and L name is equal to quote Smith, end quote, semicolon. And you recall that all this information that you see right here could all be piled up on one line, or it could be put in there one word per line. It would be really, as far as SQL is concerned, irrelevant, as long as the semicolon were after the last one. That's what determines the end of a statement. Okay, that one pulls up the birthday of John Smith. The next one, retrieve the name and address of all employees who work for the research department. That was an example we just used, wasn't it? Okay, here we have the select statement, and it's asking for the first name, last name, and address. And it's asking for those attributes to come from the employee table and the department table. Where is the condition where the department name is equal to quote research and the department number is equal to dno. Let's take a look at this query that we've input here. We have a where statement that says dname equals research. Well, in our request up here, we asked for all the employees who worked in the research department, so that right there will satisfy that request. What about this request? dnumber equal dno. Well, take a look at our from statement. The from statement is pulling information from two tables, the employee table and the department table. In order for this to work, these two tables must be linked somehow. In order to get the name and address of the employee, we need to open the employee table. And in order to find out which department is research, we have to open the department table. And the two tables must be linked. How is that happening? It says dnumber equals dno. Well, one of these two, either dnumber or dno, is the primary key in the department table. The other one is the foreign key in the employee table that indicates which department this employee works for. So with these two conditions, dname equal research, we satisfied that request, and with this one we link the two tables together so that we can pull the information that is appropriate. Let's take a look at another one. For every project located in Stafford, list the project number, the controlling department number, and the department manager's last name, address, and birth date. So, in order to retrieve the information we want, we start with the select statement, P number, dnum, lname, address, and bdate. That will pull out these specific pieces of information: project number, department number, manager's last name, address, and birth date. Then we have to identify the tables that contain these attributes, and those are the project table, department table, and the employee table. Actually, the project number is located in the project table, and the department number is located in the department table, and a last name, address, and birth date are all located in the employee table. So we've identified where we're pulling this information. Now, before we can actually retrieve the specific information about the Stafford location, we have to put in our query how to link the three tables together. And we're doing it with these statements right here. dnum equal dnumber. Well, one of those is the department number primary key. The other one is a foreign key in the project table linking it to the department. Don't know which is which because we don't see the structure of the database, but we can assume that one of them is a primary key to the department table and the other is a foreign key in the project table. Now then, manager SSN equal SSN. I believe we can determine pretty much for sure that manager SSN is a foreign key in the department table that links the manager to the primary key SSN in the employee table. So now we have linked project to department and department to employee, and by extension that means we've linked employee to project. And now we can put in our third part of our query, P location is equal to Stafford, which will pull the specific information we're asking for, the Stafford project's department manager's last name, address, and date of birth, along with the department number that's responsible for that. Oh, here's another one. This one is going to address the issue of using the same attribute name in multiple tables, and since that might take us a while to talk about, why don't we take a break right here and submit our mystery word? Have we even created a mystery word? I don't believe we have. Why don't we make the mystery word where? So submit your mystery word, and when you're done with that, Go out to our coursework section, check your knowledge on the material we've discussed in this video, and when you're ready, come on back for the next lecture in the series.